Now that we've completed the UV layout for our low-resolution character, we're finally at a point now where we can start to use some of XSI's tremendous tools to start to transfer some of this detail from our high-resolution model down onto our low-resolution guy. Right, now before I do that, let's take just a few minutes to compare some of the stats of these two different models. So if I select this, to take a look at these stats, that can be done by pressing Shift Enter on your keyboard, and that will pull up pretty much all the information on the current selection. So this will give you a breakdown of the different components. So we have how many points we have, how many edges, and how many faces. So you can see this is actually a really dense mesh with a total of about 70,000 faces all in all. Okay, also it'll give you a little bit of a breakdown on exactly what these components are made up of. So how many triangles you have, how many quads, and how many polygons with more than 5 sides. So let's go ahead and do a quick little comparison now to our low resolution character. So we had 70,000 faces on the high resolution. All right, again I'm going to press Shift Enter to pull up the stats on this low resolution guy. So the low resolution one, you can see, only has about 2,400 faces, so much lower, and a very good range for any kind of a game engine. Now the main thing that we want to look at is, when looking at triangles and quads, we want to make absolutely sure that this mesh does not have any faces that are 5 sides or more. So this is something that we're going to have to fix, because we have 2 polygons somewhere in this mesh that are 5 sides or more. So how can we locate these faces so we can actually fix those? In XSI, that's actually a pretty simple little thing to do. What we could do is up in the Select menu, if you click this to fly this little menu out, kind of down toward the bottom, you should have an option for Select N-sided polygons. So we can select all the triangles, all the quads, or we can select any polygons that are 5 sides or more. So if I click on that, and then just simply hit F to frame, you can see, there we go. There's our 2 polygons that are more than 5 sides, or 5 sides or more. So we can very easily fix that if we go down to Modify, Polymesh, and Add Edge. What we can do is just simply split these across to, instead of having one polygon here that's 5 sides, we'll just split this across, so now we have a triangle and a quad. There we are. So let's take a look at this. Shift Enter, and you can see now we have 0 polys. So the reason that's usually an important thing to take a look at and make sure that you don't have is usually polygons that have 5 sides or more are going to run into some issues whenever trying to take these into your game engine. A lot of game engines will have issues trying to compute faces that have more than 5 sides, so you might run into a pretty significant performance decrease, or your game engine may not accept this model at all if it has more than 5 sides to any face. So always a good idea to check the stats on your mesh, make sure you do not have any polys with more than 5 sides, and if you do, just simply select any of these and clean those up. So now that we have this low resolution mesh all set up and ready to go, let's now begin the process of transferring some of the detail from the high resolution mesh onto our low resolution. So that can be done in XSI using a function called the Ultimapper. Now the Ultimapper is a tremendous tool that will let us transfer things like normal data, things like depth map, any kind of ambient occlusion maps. All those can be taken from the high resolution mesh onto your UV mapped low resolution mesh. So to do this, what we need to do is first select our low resolution mesh, and then underneath the model menu, go to Get, Property, and let's use the Ultimapper. Alright, now when you run the Ultimapper, what you should see now is a mesh that sort of changes colors on you. That's actually completely normal. What we want to do is make sure we're in the General tab, and it's going to ask you to pick a high resolution source. So let's choose the high resolution mesh. Right, once you have that loaded up, it should have this loaded up as your new source. once you have that loaded up, we can actually now go in and hide that. Underneath the preview shader tree, if you hide your high-res source, you can hide or reveal that. So that at least kind of gets that out of the way. Now, what we really want to take a look at is underneath this Advanced tab. You can see, looking at this mesh, that the colors sometimes change colors very abruptly. What we're looking at are the actual tangents of this mesh. Now, these tangents are going to be very, very important when it comes to generating things like normal maps. So if you have any of these really, really harsh lines, like what we have right here in the collar, or sometimes in areas like this, these sudden changes in the tangents could sometimes wind up as creases or seams in the actual normal map. So what we want to do is adjust the tangents in this Advanced tab. So by increasing this smoothing level, what we can do is blend these tangents together. So anything down to 0, what you're pretty much going to wind up with is a harsh line everywhere, which means you're going to have very harsh lines in your normal maps. So if we take that smoothing all the way up, you see things become nicely sort of blended out. And that's exactly what we want, and that will help ensure that we get a nice, clean, usable normal map. All right, so very, very important step to take into consideration. So in the General tab, this is where we can control in the Ultimapper exactly what it's going to spit out. By default, it'll shoot out a normal in tangent space map. We could also tell it to spit out things like a depth map, an ambient occlusion map, pretty much anything that we need it to. So to turn these on, just simply turn on the checkbox, and these will all be exported and computed in one shot. So we can give these any kind of a prefix, so we'll call this Game Man, if I can spell. There we go. You can choose what kind of a file type this is going to spit out for you, a Targa, Windows bitmap, or anything else. Usually I like to leave these as either Targa or a Windows bitmap. Those two seem to give you a really nice combination of quality and a fairly manageable file size. Now in the resolution, you can choose what size of a map this is actually going to compute for us, so 256 all the way up to an 8K map. We also have things as far as quality. Now these two sliders are very, very important. The surface, distance to surface, and the depth range. What this is basically going to control is how far XSI will look to generate the normal map. Now that becomes very important in areas like this where you have a difference or a gap between this low resolution piece of geometry and the high resolution that you're trying to extract this detail from. And really this becomes kind of a fine line, because if you leave this too low, this distance to surface, what you'll wind up with is a normal map that is not able to capture all of the detail of some of these different individual pieces, like these vents and some of these other pieces around the ribs. But if it's set too high, what you'll wind up with is a bleeding effect. So areas like these collars in the back of the head or the ears, it will be looking so far that you'll actually start to get detail around this side of the collar from the ear and vice versa. You'll start to get kind of an inner bleeding or an inner penetration type of effect. So this is a very, very fine line to walk. So a lot of times what I'll do in a situation like this, you'll see that we have this low resolution mesh that has quite a bit of distance to have to cover before it can grab the detail from this high resolution mesh. So a lot of times what I like to do, just to make this much easier, is I can actually come in and manipulate and tweak some of these points on the low resolution mesh until they're completely encompassing the high resolution piece. Alright, and this will make a little bit more sense here in just a second. So what I can do is tag some of these points on the low res mesh. I can come in, and with my move tool, I can come in and start to pull some of these points out. And what I'm doing is trying to extend these points to where they extend out beyond this piece of geometry that I'm trying to capture this detail from. So what I can do, like I said, is just take some of these points, pull these outward. That way that will ensure that these surfaces are close enough to capture the detail for the normal map. And then once the normal map's been generated, I can simply come back and delete these move operators and get the geometry right back to the way I had it. So I can take some of these points, pull these outward. There we go. So it looks like we're going to need to grab a few of these points right in this area. Pull these forward because there's quite a bit of distance between those two areas. So just simply grab those, pull these forward until there's enough space to be able to capture whatever detail that we need. Alright, so things like the areas around the belt, these ribs, areas around the eyes, some of these can be fixed by just simply adding one deform operator. So if you go to Modify, Deform, a really good operator for this is the Push Deformer. So with this Push Deformer, what it will do is pretty much inflate your mesh. Alright, you can see how that's slowly inflating this. So what I can do is just give this a really low value, like let's say 0.1. That's actually probably too much. Let's try 0.05. Just enough to be able to encompass pretty much all of these areas of detail that we're going to need. So if I need to, I can always take some of these points, scale these out. Now, like I said, I'm not actually doing any permanent damage to this mesh because I can always come back and just simply remove all these deformers and all these operators once the actual normal map has been generated. So all I'm doing is really just making it easier for XSI to capture all the detail that I need it to capture. So let's also go in and tag some of these points around this backside. So we'll take these, pull these backward, again, so that this geometry is able to fully encompass the areas of detail that we need. There we are. Now to make this a little bit easier, I'm going to go ahead and turn on my headlight, just to make it a little easier to see this backside and make sure that I don't miss anything. Looks like we got a little bit of detail here that can be extended outward. So we'll grab some of these areas, pull these out. Alright, and there we go. Just undo that a couple of steps. There we are. So now at this point we're ready to generate the actual normal maps. So what I'll do is generate these. So first step is to get a decent resolution. So we'll set this to a 1024 or 1K resolution. We'll give this a nice high quality so we're able to capture as much detail as we need. In the Advanced tab, we want to make sure that we're able to get an ambient occlusion pass. So let me turn on occlusion. Now here we can adjust the occlusion that it's actually going to generate for us. So let me give this about 100 samples. We'll give this a spread of about 2, which should be just about right. And everything else should look pretty good. So now all we have to do is generate these. So I'm going to hit generate. And now XSI will go ahead and spend just a few minutes computing these render maps. So while I wait for this to compute, I'm going to go ahead and stop this lesson, and when we pick up in the next lesson, we'll have these render maps computed, and we'll actually start to put these to use.